Two point charges of plus 3 microcoulombs and plus 6 microcoulombs are placed 0.5 meter apart in A. Calculate the force between them. So here we need to calculate the force between these two charges here. Okay, so first of all, force which is equals to what? Question mark here. And what they have given the 2 point charges. Let me consider here is 1 point and here is 1 point charges, and in one of that is plus 3 and another one is plus 6, and the distance between these two charges is how much? That is 0.5 meter here. Now to calculate the force, what we are having formula, that is F equals to K q1 q2 over r square here. Here q1 q2 which is nothing but charges here, so let me consider q1 as a positive 3 microcoulombs and q2 as a positive 6 microcoulombs here, and r is nothing but here distance, so r we are having that is 0.5 meter here. Now k value what we are having that is 9 into 10 raised to the power 9 Newton meter square over r square here. Now here which is in the microcoulombs, we need to convert to the coulombs here, and we know that 1 coulomb which is equals to how much? That is 10 lakh microcoulombs. So here to convert microcoulombs to coulombs, what we need to do? We need to divide by 10 lakh here. So since we are having here 3 and we need to divide it by 10 lakh, okay? And in 10 lakh how many zeros we are having? That is, we are having that is 6 zeros. So I can write it as a 3 over 10 raised to the power 6, and when I'll bring to the numerator it will be become 3 into 10 raised to the power negative 6 here. So this is converted to coulombs here. Now I'm going to substitute this value, and similarly for this we can say that is 6 into 10 raised to the power negative 6. It has been converted to coulombs now. Okay. Now let me substitute here. Multiply. Q1 value, that is 3 into 10 raised to the power negative 6 coulombs, and the q2 which is 6 into 10 raised to the power negative 6 coulombs, and here divided by r square, that is, I have written wrong here, Newton meter square divided by, it should be coulomb square, and now r square value, that is 0.5 meter bracket square here. Okay, now from this let me start simplifying. 9 into 10 raised to the power 9 Newton meter square. Okay, here let me first multiply. 3 times 6 will be 18. Okay, multiply. Look at this, the bases are same, so what we can do, we can add the powers here. So I'll be getting that is negative 12, and c into c, that is c square here. In the denominator, c square into 0.5 we need to multiply 2 times, so I'll be getting that is as a 0.25, and here meter into meter, that is meter square. Now from this what we can do, the cancellation here, c square it will get cancelled, and 1 meter square and this meter square it will get cancelled. 9 into 18, that will be, that is 162, and look at this, the bases are same, and what we can do, we can add the powers, and since the powers are in the unlike sign, so we need to subtract here. After subtraction I'll be getting this as a negative 3 here. Okay, and 1, and the unit which is Newton here. Now divided by, only we left with the 0.25. Now 162 divided by 0.25, that I'll be getting 648 into 10 raised to the power negative 3 Newton here. Now when I'll shift to the denominator, I'll be having that is 648 over 10 raised to the power 3 positive 3, and this let me open, so I'll be having that is 648 divided by, here it is, we'll be having 3 zeros. Okay, when I'll convert to the decimal, I'll be having that is 0.648 newtons. Okay.